And welcome to lesson one of Neuron Networks for Swift. And in this lecture, we are going to cover what is a neural network and how to use them as a developer. So, an artificial neuron network is a computational model based on the structure and functions of a biological neural network. Information that flows through the network affects the structure of the neural network because a neural network actually learns based on that input and output. Neural networks are considered statistical data modeling tools where the complex relationships between inputs and outputs are modeled and patterns are found. Neural networks takes data samples rather than entire data sets to arrive at solutions, which ultimately saves both time and money. So, neural networks have three layers that are interconnected. The first layer consists of input neurons. Those neurons send data on the second layer, which in turn sends the output neurons to the third layer. In this particular neural network, you have two hidden layers to be counted as one layer. So, how can we use a neural network to our advantage? Let's say that this is an image that we want to reproduce through a neural network. We want to get an output from the neural network that is either solid, vertical, diagonal, or horizontal. Why can't we just put a protocol in the input, feed forward the network, and get an output that we desire? Because neural networks do not work that way. We have to come up with an algorithm and allocate some type of algorithmic calculation or function to train that network to giving us an output in which we want. So, for example, in the particular image that we're using for an example, we are allocating a number between 1.0 and negative 1.0 for the brightness. So the darker the picture, we are going to allocate negative 1.0 for that. And to brighten the picture, we are going to allocate plus 1.0. So we're going to allocate black to negative 1, and we're going to allocate white to plus 1 with gray at a 0 value in the middle. At that point, this gives us a input vector to work with. Okay? And now we have values to work with to actually create and implement a neuron. So now that we have our neuron, we actually can add or take away weights to make the neuron input as we like. As you can see here, the black line represents the negative values, okay, which implement a darker shade of the picture, whereas the white line is thicker and represents a lighter shade of the image and a positive number. So, given the values, we get an output that to create our neuron that ultimately adds up to negative 1.075. So that gives us a value for our neuron. So next, once we have that value input or that activation function, we put it into a hidden layer. But before we put it into a hidden layer, we squash the value or compress it into a sigmoid value. And in a sigmoid squashing function, we take the x and y values, and where they meet on the sigmoid is the actual value. The further the sigmoid goes out, the higher the value. Okay. However, no matter what value you have and where you start, the answer will always be between negative 1 and 1. So now that we have our input value and our input layers or layer, now we have additional layers, or one additional layer in this particular case, which is our first hidden layer, and it is of a sigmoid value. We add two more layers, two more hidden layers, to give us two sigmoid hidden layers and one rectified linear layer. And a rectified linear layer or unit is where if the number is positive, you keep it. If it's not, you ditch it. That's simple. Then we have an output layer. Okay. So in a perfect world, we could have put in the protocol a specific set of rules or guidelines and get the output that we want, but that's not the way it works in a neural network. We have no control over an untrained neural network. And so if it's not trained and we don't have a trained model for it to follow, we get everything but the output that we expect. So how can we, even with rectification, without being trained, we still have a crazy high error rate in our output? So how do we get the neural network to give us the output that we're looking for? Well, we have to train the network. And we do that with what we call back propagation. And so we will continue part 2 of this lesson in back propagation. See you there.